is Katie Schauer, and I will be your host for this session. You've joined us today for Running Closer to Capacity in Mining with Braincube. And our presenters this afternoon will be Ben Kojo from Braincube and Jarrett Messing from InSource. Before we begin, I'd just like to cover a few things. First of all, some housekeeping items. Please use the Q&A box for any questions you may have during the entire presentation. We will be holding all questions until the end of the session, but you can enter your questions at any time. The phones are muted and will remain muted because of the call volume we're expecting. But again, you can use that Q&A box. We are recording today's session, and we will be sharing that out on our website at a later date, probably within the week. And so you'll be able to see it on demand almost immediately with the link that you've already shared. If you want to share it with a colleague, feel free to send them the link to the registration page. All right, so real quick, just a reminder and an introduction of InSource Solutions Group. We are the largest North American partner for Aviva as an Aviva Select partner. We are made up of several different territories, and I'll show you those in just a minute. And today we're focusing on our premier partner, Braincube. So InSource Solutions Group ignites transformation. We are empowering people to shape the future of manufacturing. So we want to help you do what you do, but do it better. Why do we do it? We want to strengthen our communities by empowering manufacturing and industrial operations. And we want to help you achieve those desired business outcomes and succeed in the future as well. We are InSource Solutions Group, and we are redefining redefining the future of industry. We take your ambition and turn that into action. We're helping organizations just like yours thrive by connecting your people, your processes, and your technology. And we deliver digital transformation solutions and help you manage every stage of that life cycle to help you outperform at scale. Again, we are InSource Solutions Group. We are made up of InSource Solutions, who is driving digital transformation in the US, and Simsoft, who is driving digital transformation in Canada. You can see here our territory. So we cover the eastern part of Canada, the upper Midwest, California, and the southeastern United States. So what's the real problem? You're investing millions, but are you seeing results? We know that 73% of manufacturers lack a clear roadmap when it comes to their digital transformation plans, and up to 70% of those transformations fail due to poor adoption. 30 to 40% of digital projects deliver the ROI. We'd like to see that number be higher. So what's the difference? Tech doesn't drive success. Technology alone is not enough. People, process, and execution drive you to success. From technology to transformation, we make a difference in your business. We're not just focused on the technology, like I just said. We want to work at every level with you, from industry expertise, your people, your process. We are your end-to-end lifecycle partner when it comes to digital transformations. And our result is over $1 billion in client transformations. This is the digital transformation lifecycle, and we can meet you wherever you are on this lifecycle. We can help you define and plan. We can help you enable, operate, and optimize. We're here at any point and at all those points. And then we empower our clients to turn that ambition to action by working with all of these industries you see here, plus others. And we've helped 80% of Fortune 100 manufacturing companies reach their goals. Whoops, sorry. This is just kind of the digital transformation lifecycle on a more linear view at the different levels. And then again, our partner technologies, Aviva, Braincube, who we're working with today, Odyssey MDT, and Planet Together. At this point, I would like to hand it over to Jarrett and Ben to get us started with the presentation. Ben, it's all yours.
All right, thank you. And hopefully you all can see that now.
Yes, we can see it.
Great. So today I'm going to be talking about running closer to capacity in mining, even as conditions change. I'll get into exactly what I mean by that. But first, as mentioned already, today speaking, it'll be me, Director of Technology and Operations for Braincube North America. I've been with the company for 9 years now, and I know a lot of how we use it, our technology as it's evolved, our roadmap, and things like that. So my hope is that if there are any questions today, I should be able to answer them, and I'll be leading the majority of this presentation today. And then I'm accompanied by Jarrett Messing with InSource, and he will be my cohort as I go through all of this and talking a little bit about how InSource can help us make a technology successful. Just a little background on Braincube. I won't spend too much time on this. Our focus today is delivering value with real-time process optimization. Braincube has, saved a bunch of customers a bunch of money, and our real focus is leveraging our proprietary cross-rank AI through our TPO, which is our acronym for real-time process optimization. And we build all of that on top of product clones that help really to massage the data to make it ready for doing a full process analysis. And so I'm going to talk mostly about our TPO today because that's where we're really focusing our value. And the core problem statement that we want to talk through when we talk about our TPO is, you know, conditions, right? So our processes today all have lots and lots of conditions that we need to be reactive to. And we all have in mind, ideal targets, ideal goals that we could be reaching uh, when we're running in the best case scenarios. And we all have ideas of situations that might arise that we know we can't run as good as we'd like to, right? So, in the mining industry, for specifics, we have, hardness, ore composition, moisture, things like that. And so when we have a consistent supply, we can, react with that consistent supply and build some rules that will give us, the best throughput, the best yield. But that's not realistic that that's going to stay the same. Our supplier changes constantly. Our conditions change constantly, and this is true. I'm talking about mining. This is true for any process that we see today, right? Um, and these process conditions that we need to be reactive to, they might be short term, right? They might come as frequently as every 5 minutes, every truckload, everything like that, or they might be long term, right? There might be seasonality implications, with ambient temperature, ambient humidity, things like that. And we don't need to just know when we're running a certain supplier what we should be doing with that supplier's data. We need to know what do we do when we run that supplier in the winter versus when we run that supplier in the summer, right? There's very many variables at play here, and we want to take a look at all of them. And one of the things that we see as an existing challenge or a gap today for a lot of companies is it's focused on optimizing individual assets, right? So getting just the throughput or the health out of a single piece of equipment. And what Braincube really likes to do is focus on the entire production line, right? So what we want to do is say, hey, looking at how everything behaves, what's our maximum final KPI that we can get, right? And as a part of that, right, when we start upstream with the ore characteristics, that changes how we go to grinding, and that then affects how everything downstream gets impacted. It's not just fix the problem at one point in the process and now everything's hunky dory. It's I ran differently due to a reaction of our different supply. Now my downstream process needs to run differently to compensate as well, because presumably I didn't fix 100% of the problem upstream. And also I might have introduced new variability into the process as a result of reacting to it. So we don't, again, just want to look at my current asset and say, hey, here's how I can run best in a static, best case scenario in my steady state normal condition. How can I run this asset best? We want to look at, for all time in this condition, how can I run my entire product line to get my maximum goal? And so that's the difference of focusing that we really want to look at when we're looking at Braincube. One of the things that I see a lot in our existing customer base is process changes that come from running trials, right? And I'm sure a lot of people will have that experience as well, where a engineer or someone comes up with an idea of a way that we can run better. They submit a request to run it as a trial. Then 2 to 4 weeks we run that way, and sometimes it's better, great, and then we lock those in as better run parameters for the next year. And what we see as a result of that sometimes is, again, it's not being condition focused. Those 2 to 4 weeks, we had the best supplier we've ever had. So we adjusted all of our run ranges to accommodate that. And then we go and look back at the following year, and it actually wasn't better overall. Sometimes it's even a little worse. So setting those fixed static run ranges to reach those best targets without considering the condition is a very large risk, I would say. And because of the lengthy process to collect the data and react basically to building a new trial, inputting a new set of standards, that's tough. And so if you get locked in on the wrong path, you're locked in, and you need to go and do a bunch of development work in order to course correct. And so again, the problem statement, the mission with our TPO will be to continuously assess what the conditions are and optimize, give a prescription that optimizes those current conditions to move forward.
Ben, if you don't mind me just interjecting real quick, I
Yeah.
think you did a really, really good job summarizing the problem statement, and I guess that would resonate with most people on the call today, right? Organizations know that there's variability. They know that their set points, their targets either are continuously changing, they're drifting, or there is, different achievable goals based on those conditions that you spoke of. Why do you think organizations aren't able to adjust those more frequently? Why aren't they able to react?
Yeah. Yeah, I think that that's accurate. A lot of our customers are well aware that processes have natural drift, and that static things won't be relevant in the near future, or definitely not the long future. And the answer to what I see why customers don't do anything differently today is because it's hard work. It is a lot of work to qualify what is drifting, what has changed, what we need to be reactive to, and how we want to react to it in the best way going forward. And so again, part of the value proposition here is to make that work easy and readily available. Thank you. I'll move on to the next here. So the thing here is that we know conditions change, but we don't change what our targets are, right? And what I mean by that is we have an idea in our head of what good throughput, good yield, good performance looks like. And like I said at the start, we know that conditions have an impact on these things, but we are setting goals for operators that are performance based and condition independent. We're basically taking an average of what the conditions are normally during run conditions and then saying, okay, we're going to target these things. And the result of that is sometimes in very tough conditions, when we can't run our best, we end up with operators that make excuses. And sometimes those excuses are valid, sometimes they're not, right? But basically, if you go out and ask the control room, hey, why are you in a throughput limited mode? Why are you not reaching your targets? It's always going to be because X, Y, and Z, right? There's always going to be a reason for it. Of course, no operator is going to say, oh, it's because I don't feel like reaching the target. They're going to give you a reason. And maybe the reason is valid, maybe it's not, but you don't really know because you're speaking from the operator's feelings right now and not speaking with data, right? And so what we want to be realistic with is we want to be realistic with setting targets that are based on those conditions. If I have a bad supply, I know that I'm going to get less throughput, less yield. I shouldn't be setting my best of the best target for the operators to reach. I want to be setting an objective to them that is obtainable for their current settings, and so that they can actually strive to reach it, hopefully reach it, and feel good when they do, rather than have an objective in front of them that they just dismiss as unrealistic. And whenever you come out and ask about it, there's an excuse for it. So that's what we're going to try to do with our TPO, right? We want to remove static targets, say the last time that we've ran under these constraints, our best of the best days were, at a specific level of throughput, and it's not going to be our best day ever because of our constraints. And we really want to reframe those objectives to meet that idea. In line with this, one of the things that I've seen historically is a big focus on process stability, right? And so I want to hit that as a point as well. Stability is something that we've been targeting industry-wide, or not just industry-wide. Every manufacturing process has been targeting process stability. And part of the justification for that is we know that variance in the process results in unpredictability. It results in a chaotic state, an unknown state. So we want to get stability, and that way we can get predictability. But a big part of what Braincube wants to focus on is optimize, not just stabilize. And there's a lot of talk, even in Braincube, of can we stabilize and then optimize? Sure, but if the goal is really optimize and stabilization is a means to that end, then why not optimize while you're stabilizing all in one, right? And that's the goal of a really steady prescriptive rule set, is to have a stable process on the optimal, again, for right now. And to tie that back into what I was saying about targets changing, if I have a shift that keeps my process completely stable the entire time, meanwhile my ore conditions are changing and things like that, that might look really good. It's impressive that they're able to react to the change in raw material and keep a stable process. But if shift B is able to react to better ore and increase my throughput, I should be rewarding that, not just the stable process, right? So looking just at stabilization limits the view of what actually good production might look like. And so again, you do want to keep the process stable. I don't want to say, don't do that, but we want to focus on realistic targets for the conditions. And if the conditions change, there's a lot of variance in the conditions that we need to react to, then we need to have a reactive process as well.
Ben, that matches the conversations that we have with customers all the time, right? Like you said, for the past however long, it's been about stability, and we're trying to change that conversation to be not stable on your entire timeline, right? But stable within similar conditions, right? Like you said, using that example, if you ran the same supplier January, February, March, then you changed and you went back to that supplier at the end of the year, you may not expect to see stability across the whole year, but you should see stability that matches the beginning of the year and the end of the year. And our experience is that most people understand that and can relate to that, although it is a little bit of a shock, right? When you talk about moving past stability, is that your experience working with customers as well?
Yeah, and I think it's definitely almost an older school practice that I've seen a lot of, right? Is again, I think I said it before, but optimizing at steady state, right? I mean, we're going to assume that we reach a steady state pretty consistently, and that we want to optimize for when we are in that steady state. But even the steady state conditions, right? We're defining those statically. We're defining the targets of those steady state conditions statically. They're not reactive, generally speaking, to any of the inputs that we can't control, right? And it's not because we don't know they're there. It's because it's too complex today to account for everything. So we're taking our engineering hats and doing, an assumption on covering the largest percentage of a controllable situation that we can. But we know in the back of our minds when we do that, there's a lot of opportunity to be better if we can be specific to our situations. And so yeah, I think when we talk about, as you phrased it, moving beyond stability, there are certainly concerns about introducing variance. But oftentimes, what I see is when we optimize and we optimize well, we do result in higher stability that is condition dependent when we're looking at a short-term focus. And what we reduce a lot, and I'll talk about this in the next section a little bit, is overreaction, right? Because the same sort of things that might drive your process in a good way during steady state hurt your process during other conditions that you're not considering. And so if your operator has a procedure, a list of steps that they need to run through in order to react to a process upset in a specific condition, and none of those work, then they're going to get to the bottom of the list, have changed 12 dials, none of them work, and they're going to start tweaking their own things. And so really, again, having the rule sets to be reactive to the conditions is the key focus. So I said this already, this will be the next section, just where our existing technology is falling short. And again, this is through the lens of mining, but it's pretty process agnostic, right? We've went through a process of collecting more data that's been decades in the making. Historians, MES, all of those are really good stuff. They are critical to having a healthy data ecosystem, right? And then we worked on increasing visibility for operators, right? Today, when I go and visit a customer and look at the control room, I see 8 to 12 displays all around the room, lots of dashboards, lots of visibility. And then visibility is great, but what happens if someone misses a visual notification? Well, we added alerts, right? So now I get an email, I get a text message telling me, hey, something is wrong. And one of the things that's hard for operators today that I've experienced is they're over-informed, right? And all of it's important, but what they actually need is they need to know what to react to and how to react to it, right? And so having all of this information is just a level one of, hey, something is going on. But the first question is, great, something's going on. Is it something that I even need to worry about? If it's on one of my 12 displays, I assume that it must be important because that's expensive real estate. But is it actually something I need to react to right now? And then two, what am I supposed to do about it, right? And so maybe I have a standard operating procedure that I can pull up. I can say, okay, when the 7th piece of information on the top left display goes red, I need to do 1, 2, and 3. But a big limitation with that is not having SOPs for everything, and then having new and green operators entering the control room as we go through, employee turnover, things like that, not knowing what the procedures are, not knowing where to find them if they do exist, and just generally not knowing what to do when an existing display is flashing red, right? And even if we go and look at the old operators that do know what to do, if you ask 2 different crews, you might get different answers. And again, that's because historically our manufacturing processes have been driven by these operational experts who have learned the process by putting in decades of their life to it and have their own feelings for how to react. But even those feelings that they have, while they're consistently good and correct, they are with the conditions they're familiar with, and they're not data driven. So that's, again, the gap that we want to try to correct is focusing on with the data, what is the meaningful action for the operators to take consistently to improve the situation. And I hit on this point just earlier, but the other big symptom that we see from this, from the existing tools and the existing visuals, is because those, again, displays are static, what the information that they're providing is static, is there's overreaction. In any given specific condition, I might not want a piece of information to be reacted to even when it's read. But because my display is static, I've put all the pieces of information in there that might ever be relevant to an operator. And an operator needs to know, oh, when we are in a manual mode, I care if this number turns red, but when we're in an automatic mode, I'm just going to let that number be, right? Or with existing APCs, right? The one thing that I've noticed a lot of is, okay, we have a protocol, a procedure basically, that the operators see something go and they go and shut off the APC because now they're going to run in a completely manual mode, right? And so all of these data systems are great, but they're built in a static condition, and they can't handle all the dynamics of a real process. So we want the operators reacting consistently. We don't want them going in and turning off systems like APCs when they know better. We want, again, for lack of a better term, a consistent, predictable, and appropriate response. And we want to deliver those instructions to the operator to say, here's what you do. And the next time you're in this situation and it's a different operator, a different crew, here, we're going to tell them to do the same thing. And so the final point to hit on in all of this is in avoiding, information bloat, over information and things like that. One of the things that we need to be very intentional about in building or adding to the information an operator is receiving is we need it to be very high fidelity, right? We need the operators to trust it. In my experience, operators will immediately start dismissing anything if it's wrong even 5% of the time. And so to again, the real estate in a control room is expensive. The real estate in an operator's mind is expensive. In order to capture that value, we really need to have a system that has super high accuracy, and a big part of that is being reactive to the current conditions. And like I kicked it off with, if we have a KPI target that is not condition based and the operators aren't reaching it, you're going to go out and ask them, and they're going to have an excuse every time. But if we have a display that tells them, based on here's the condition, the constraints you're currently in, and based on those constraints, here's a realistic target for you to get. Now you can go out and ask them, why aren't you reaching that target? And as part of that, our TPO screen as well, you have the recommended ranges. Why aren't you in those recommended ranges? So that's sort of the conversation to further there.
Ben, I think, again, a lot of those things truly are the experiences that we have with our customers as well, especially the part about trust. And that's something I'm going to speak to in one of the later sections. It's not just about having reliable technology that adapts to the scenarios. That's critical, but it's also super important that, like you said, the organizations, the people actually understand the tool. They trust the tool. It's not enough to just say, hey, here's a tool that works. They have to understand what their role is in relation to it. They have to understand that it's not replacing their job, their knowledge, how they work, and they have to understand its place in the business process. When should they consult this tool versus that tool? And that requires a lot of hands-on coaching and communication. The other thing you said that I thought was really accurate and connects to the theme about static versus dynamic is a lot of times what's on those dashboards and what alarms are set up are really to just avoid the really bad, right? An alarm gets triggered when something is pretty bad or really bad. A dashboard flashes yellow when things are kind of bad, and then red when they're really bad. But they're not about, hey, when things are just a little suboptimal. or hey, when you could go above your target, right? Because there are times where, hey, you've been averaging, you know, 1,700 tons per hour, and that's a great average. But hey, you could actually be doing, 1,800 based on the current conditions. No alarm is going to tell you that. No dashboard is going to tell you that. And I think that's where RTPO really stands out as, kind of cutting edge. But I do want to ask, hey, you talked about more sensors, more historians. There's MES, there's APC, there's dashboards, there's alarms, and now there's RTPO. Is there a risk of just adding another tool? Does this replace something, or how do we help make sure that this isn't just another thing that gets ignored?
Yeah, and I think that is a very important consideration. I think it's something that you'll hopefully help talk about as we get into the OCM slides. But in short, it's again, to reiterate what I said, it's very valuable real estate, and we don't imagine today that we're going to replace an existing DCS or anything like that, right? But we do believe that a lot of the information displays that exist in a control room are just information, and what RTPO can deliver is a prescription, right? That's the term that we like to use, is here's what to do now. And we follow up with, hey, are you doing it or not, right? And then, are you getting the results you want? So our hope is that our display, our prescriptions, can be the first stop for operators. But then there's an additional component to that as well. Braincube does, we have a display that we ship with RTPO, but that's not really our focus. Our focus is really on the computation, on the results, and giving those prescriptions. So we have, and I'll get into my next slide here, and talk about the solution itself. We have the capability to connect to a variety of systems, and we have a number of usages right now that use different connections. So we can do open loop control, right, where we use that display for operators to then make the reactions. We have customers that have us write those targets, those run ranges, right into their APC system. So then they have essentially a condition aware APC run ranges. We have customers who let us write set points back to their PLCs. And then somewhere in between there as well is, we can write the data to an MQTT broker or put it on an OPCUA server, things like that. And you can integrate that data into existing displays if you want to. So rather than trying to take over the control room or replace something, we want to enhance what already exists and add to those prescriptions. I'll talk a little bit more. So RTPO here is our, Braincube's proposed solution to all the problems I just talked about. And I kicked it off at the start, but Braincube technology relies on a few key components, right? So we have our product clones, we call them, which is really a look at the entire process holistically, so that I'm optimizing for a KPI with levers throughout my process rather than focusing on every individual asset, right? It's definitely interesting if I know that I have a bottleneck at my crushers. It's definitely interesting to just maximize crusher throughput, right? That is basic principles. Optimize my bottleneck, my entire process improves. But there are always side effects of optimizing any KPI, and those side effects can be downstream. And with a holistic view, with a product clone, we can say, what are those repercussions for optimizing on this single asset? We can say, hey, here's my whole product line's actual KPI. yes, optimizing the crusher is one part of that, but optimizing everything in conjunction is a piece too. And once I move my bottleneck from the crusher to the cyclones or something like that, I want to be able to react to that as well. And then again, the thing that I stated up front, every time I react at any single one of my operations, I am upsetting the process downstream, and each of those downstream processes need to be prepared to handle the new incoming material, whatever that means. And so really having that holistic product view lets you get that view that gives you settings and conditions to control your process. Then in addition to the product clones, Braincube relies on our cross-rank AI. This is a proprietary tool that Braincube has developed and has been using, out in the field with our customers for over a decade now. So it's really well vetted. It is a deterministic and prescriptive tool, right? So prescription being one of those keywords. It will never come up with something theoretical. It only comes up with results of where the process has actually run today. So when you're in a new condition, Braincube looks at the last time you were in that condition or a similar condition and prescribes the rules that are best for that current condition. And that's what the cross-rank AI is really focusing on, is how do you get the best of the best, or how do you reproduce your best of best days, your best of best runs, right? Given the situation. Again, because it's a deterministic algorithm rather than non-deterministic, we can give full explainability, right? We're trying to avoid the black box effect. When we get a prescription with our cross-rank AI using our TPO, we're able to dive into the tool and fully explain where that prescription came from, what runs we're referencing as good production runs, and understand why those rules are actually creating the best situation. And as I already mentioned, we can be closed or open loop control. So if you have the operators intercept it, use their own screening for what's good or what's bad, throw that in, feed it into an APC. APC has some guardrails on it. You can do it that way, or write it back to the set points. And one of the big concerns that we see with like machine learning algorithms and things like that is a lack of guardrails. But because cross-rank AI is leveraging how the process actually runs today already, there's almost natural inherent guardrails on that, because it's never going to come up with something that you don't already do. And so in the end, our goal with RTPO is to answer, the questions that we've talked about through this process, right? Based on my current conditions, what's my best achievable outcome? Based in reality, here's what I can actually realistically expect to achieve. Then here is a set of recommended prescriptions in order to achieve that best case scenario. And then we provide information on, are the operators actually following the rules? Where are they currently? How long have they been following the rules? Are they not following the rules at all? And that type of information. And then finally, the final piece of information is, great, I'm following the rules. Am I getting the results that I expect based on that, right? And so at the end of the day, I want to make sure that I implemented this tool. Am I getting the actual lift on my KPI that I wanted to see? So that's the holistic view there. But as we already alluded to, the technology is just a small part of this entire equation, right? A big part of this process as well is getting the operators to buy in, getting the operators to listen, and really changing the organization from one that focuses on operators just driving the way they're used to an organization that drives with data, that has meaningful and intelligent decision-making process. So I'll hand it off to Jarrett to talk about OCM.
Thanks, Ben. Yeah, I think a couple times throughout this, you've raised the point of operators, organizations needing to trust the tools. where you've talked about how the tool can, Braincube or any tool can give out perfect prescriptions to help solve all of your problems, giving all of these changing conditions, and that still sometimes isn't enough if people don't trust the system, they don't know how they're supposed to interact with it, and they don't know how or what the impact is going to be on the end result. And this is something that the InSource Solution Group helps organizations with all of the time. We have an entire practice dedicated to organizational change management, or OCM as we abbreviate it. And we do this for all types of tools, but really with Braincube, there's a really fun and exciting challenge, because when we see these organizations struggle with adoption, there's often a very tangible and measurable impact that we're able to make just by getting people to use the tool that's already been set up. And there's an example here of how we worked with a Braincube organization, or an organization using Braincube and suffering from that exact problem, right? They had Braincube set up. The results had been essentially validated by the organization responsible for analytics and optimization, and still they weren't seeing the full improvement that they expected. So they partnered further with Braincube, they partnered further with InSource Solutions Group, and that's what we sort of set out to solve. And in short, the organization needed to understand why operators weren't following the guidance that was given, right? So InSource sent a team to the complex, to the site. Our team members worked with the on-site team to uncover the different root causes. And essentially, as you might expect, it really boiled down to the fact that operators, supervisors, managers hadn't been given a deep enough understanding of what Braincube was, how it was generating those recommendations. And because of that, they didn't have that full trust in the system. So we work with the organization to develop clear tasks defined for each role in the organization on how they should be using Braincube, making sure that those tasks were built into the routines that they were already familiar with, things like shift handovers, daily, weekly operations reviews. We set them up with activities to monitor adherence to Braincube's recommendations and ensure that those were agenda items on those daily stand-up meetings. We did hands-on coaching and reinforcement with multiple levels of the organization, ranging from supervisor through the or operator through the individuals responsible for setting up the platform, tweaking the recommendations, and making sure that everybody understood what problems they were solving with Braincube, when they should be using Braincube, how they should be relying on it, and making sure that it really got baked into their existing ways of working. And by ingraining the tool in their existing processes, the organization saw increased buy-in, increased adoption, and then the result that they were attempting to achieve, which was an increase in overall throughput through the mine.
And I'll just throw up this slide real quick. Don't need to talk too long to it. This is recorded, so you can go freeze frame if you want to stare at this slide for longer. But for our gold mine use case, Braincube worked with InSource. We got a 1.5% increase in throughput in year one, roughly 15 million in gains. We've identified a 2x potential on that, and so it's about 47 tons per hour. So there's a lot of opportunity there. And then I will transfer into a Q&A if there's any questions.
Thanks, guys. So yeah, if you have any questions, please feel free to put them in the Q&A box. Hold on one second. It looks like somebody might be typing in. Let me look there. One moment. Yes, this is recorded and we will be sharing that out with you. So you'll be able to access this using the same link that you used previously. That was an easy question. I could answer that one. Let me see here. Don't see any others at the moment. Just make sure I didn't miss any. So I will ask this: are there any key points that we want to make sure our audience walks away with? If they had one thing to walk away with, what would be that one thing each of you would want them to remember from this presentation?
For me, the biggest thing to remember is that the existing way of doing things. It's the theme of the entire presentation is static, but we all know that conditions are dynamic and important, and we completely understand why existing tools optimize the most common scenario. But what we're working on today is a tool that's reactive to the process to optimize for this moment in time, and then the next moment in time, and the next moment in time. And so that's the big takeaway is what's the value to you in terms of being able to say, in this moment in time, how do I run the best that I can run?
Great.
I echo that, and my large takeaway would be that when organizations and individuals think about solutions built and meant to either stabilize or optimize, it's important not to think of those as solutions that run on an engineer's laptop or are done in a back office, right? In order for these tools to make an impact, they have to start with operations teams and end with operation teams. And I think that's another thing that really sets RTPO apart, is that it's in front of operators, it's in front of supervisors, and it's giving them information that's critical to them, for them to improve the process. It's not theoretical, it's not a science experiment, it's true process optimization done in real time.
Awesome. It doesn't look like we have any other questions at this point. So I will say, if you do have questions in the future, you want to ask us anything, feel free to connect with us on our website. You can either go to insource.solutions or simsoft.com, and you can reach us on either website, and we'll be happy to help you out with that. If you want to set up a demo or explore more about how this can help you in your processes, that would be a great place to start as well. I would like to thank Ben and Jarrett for presenting today, and thank you all for attending. We look forward to seeing you next time. Thanks so much.
Thank you.
Thanks.